Hello. In this lesson, we are going to do some basic elements in motor control. The most fundamental object that we control in industry is a motor, whether that be through a contactor or just, conveyor belt. The motor is the bedrock. That's why most people will take a motor control class as a part of their education. But the PLC does some stuff which is akin to motor control, but in some motor control concepts, if you know them, will carry over, like elements like a seal-in circuit or a interlock. Those would be things that carry over. But this is a Siemens flare to it. So here's our network, and this is a setup. And for sake of just being general and ease, everything I'm going to do here is going to be called input 1, input 2, and output, because really an input like a proc sensor or a limit switch or a push button, those all function in a similar way of sending a high signal or a low signal to the PLC. Same is true with an output, whether it be a light, a motor, a relay, a solenoid. It's just the PLC turning on an output at a certain time based upon the logic. So here's our basic rung. And if I want to do a seal-in, so I'm going to identify something as a stop button and a start button. And if you're doing electricity, order matters, but in PLC land, it kind of doesn't. Either way will work. And if I set up a circuit that is like this is our input 1 and input 2. Input 2. I can then turn on my, use this output, energize output, and then turn on output number 1. Pretty cool, pretty simple. This is an AND circuit. So now I'm going to compile and download. I know, riveting stuff, watching something download. And so now it's going to ask, do I want to overwrite main block 1? I hit yes, so it's loading configuration. And everything was loaded successfully, so I can hit my sunglasses and go online and I can monitor. Once again, I'm looking for green here. If green is good along the side right here, and if it's in yellow or orange or whatever you want to call this, then we're good to go. Now, quick word of note. Right here on the right side, you'll see an operator panel. The only way for me to stop and start the PLC is through this operator panel online. I will not be able to do it if it at the controller, like other models of like an Allen Bradley controller has a switch with remote and run. The Siemens, it's all through the software. So I'm going to clear that out, and now look, here is my input 1, input 2, and output number 1. Again, green means there's power. The blue dots mean nothing is engaged, and all the output is doing is, remember, is saying, is the input high? If it is, return true and allow energy to pass. So if I flip on a switch, it's true. Flip on the next switch, now everything is good. Yay, my output is on, my motor's running. But the problem is, unless I have a sustain, like a toggle switch that stays on, if I have a momentary push button, so if it goes like that, it won't stay on. I wouldn't physically need to pay someone to stay there and hold a button, and that's not a very efficient use of time. So now this is why we use seal-in circuits. And so for me to use a seal-in circuit, I'll go offline, and what I will do is basically branch around what I'm calling my start button. I'll call input 1 my start button, and if I want, I'll change this. So let me go into properties, and I'll change this to start, or I'll go into my tags and rename it. Sorry. Or start. It's been a long night, so let me go show all tags, and I'll rename input. Well, I'll give it a comment of start and stop. Okay, so I can keep track of things. But this is how. So by hitting this button here, this is opening a branch, and this will close the branch. And I just do it around my start button. And now what I can do is just take whatever my output, whatever I'm turning on, output 1, and place it here. Because what we're basically doing is saying, if input 1 is true and input 2 is true, turn this on. Or if this is on already and this is on, keep this on. So when this isn't running, this will be false and this will be false. But when I hit this online, this turns true, this stays true because it's a normally closed stop switch. At least that's what we're doing in our simulation. This turns on, which then makes this true, so then I can turn this off. So let's demonstrate this. So load. Go online and you will see. So here's my stop button. That's engaged. It's green. Now if I hit input 1 and turn it off, guess what? It stays on. So this is our sealing circuit. Now I could have made this whole part here and just put this here instead and just reverse the order. It doesn't matter. It's like saying I like apples and bananas or bananas and apples. The meaning is the same, just reversing it through. But this is our basic seal in. And by seal, this is what I mean, seal in my bad handwriting. So that's how I can seal in a motor. But again, if we've done motor controls, we know there's things called interlocks. If I have one motor controlling reverse and forward and this, that, and the other, I need to make sure that there's things in place to keep the reverse from reversing when the forward is forwarding, or you get kablamo. Well, that's fairly simple. So if I go down network 2, I'll just copy and paste this logic because I'm kind of lazy and I want to. It's easier this way, and I can just change the inputs. So here's my inputs, but now let me change this to output number 2, and change this to output number 2, and I'll keep the same stop button, but I won't. But I'll momentarily keep the same input just for a sense of argument. But if I want these to run independently of one another, so right now the way it's set up, if I make this input 1 true, both outputs are going to turn on. So if this was forward and this was reverse, we'll have issues. But if I just add this, an examine off command, and then put the other motor in there, because remember, what is this saying? This is the same as me saying not. So remember, when I see a command like this, this is the same as me saying not. And so what this is saying was input 1 is pressed and input 2 is high, and input 2 is not running, turn in output 1. And let me make this output 1, sorry. So input 1, input 2, output, when not input 2, output 1 turns on. And then down here, when input 1 and input 2, it turns on. Now, let's see if this fixes it. And for some of you might say, hey, there's an issue, and I'm doing this on purpose. So let me download this, yes, because I want to highlight something. So right now this is on from last time. So let me kill that. So now I got both my inputs not running. So let me do my push button and see what happens. Wait a second. I just turned this on, but why isn't my output 2 running? Okay, let me just hit my stop button. Okay, and now I'll turn my stop button on. Why can't I get output 2 to work? Well, remember with the PLC will always scan from top to bottom. And in this case, because this is the same and this is the same, I will never be able to turn this output on because it's going to read this one first. And so when I'm using the same input here, even though because this is here, it's never going to turn this on because there's never going to be a time when this is not going to be off there when I have the same input. But there's a workaround. There's 2 workarounds. The first workaround is this. Have a second input. So you have a button that starts it in the forward, and you have a button that starts it in reverse. So now watch, if I go online, whoops. If you see this, means that there's what I have here does not match what's online. All I have to do is download, and it will fix it. So I did that on purpose, or I did it off of memory. So now I monitor, and now watch what happens. If I set this up, let me hide this so we can see it better. Turn on a switch. Ta-da! That's running, and so keep that on. And if I try to turn on this other output, I can't. My other motor won't start. So now if I hit my stop button, drops everything out. Now I can start my other. But see, if I try to engage my other push button for my forward, it's not working. So that's one way to deal with that. But it's going to require another switch no matter what. Let me go offline. The other way to deal with that, if I have one input to rule them all to one start button, I can just put in basically a toggle switch that will basically work as an input output, or a forward and reverse selector switch. So if this is, I could say on a selector switch that this is reverse and this is forward, but isn't this also saying not reverse too? Because logically speaking, forward is not reverse, isn't it? So if I have a selector switch that has only got a hot and a low, I could do something that looks like this, and it could still give me one push button to turn on both motors and just make this be my differentiation between forward and reverse, rather than having a forward push button and a backwards push button. Either way works, as I will show you. So if I go online, you'll see that I have an output off. So then I'm able to turn this on, and now I'm going forward with a momentary, it's still staying on. If I try to engage if I try to hit start again, nothing's going to happen. Sweet. Hit stop, everything disengages. Let me flip over to my other setting, and now if I hit start, notice it actually works this time, unlike the first time through. So if you're going to do reversing motor starters and things like that, you won't be able to have one input to control both motors unless you have a selector switch or some other criteria to make it run. So a common mistake that many people make. So the last thing is I'm going to show you the garage door program on Siemens, because that's one of the most common beginning programming setups for students, like stoplights and programs. So if So I have this input right here, and let me go in and start and just relabel some stuff. So pause. I'm gonna pause. So I just took a second to rename some stuff. So startups, and then I have a start down. So let me just show you this down. That way I can clearly show this. So there's motor up, motor down, start up, start. Stop is the same. Motor down is not running. Motor up is not running. But here, this is saying go up until you are all the way up. And if I do a quick change, now this is what we call the traditional garage door circuit. Okay? So start up, stop, motor down. This is saying when start up is push button is pressed and stop is high and the motor down is not going and we're not at the up limit switch, or the up limit switch is not, I'm assuming, a normally open limit switch, then make the motor go up. Conversely, if the start down button isn't pressed and the stop is engaged and the motor up is not running and a down limit switch is not engaged, let the motor go down. This is our typical garage door circuit. Because what we're doing is having the motor cut off at a certain point with a physical limit switch or some type of sensor to say, hey, it's reached its end of travel. So I load. And now I can go online. And so now I'll engage my stop. And the garage door is down, so I'm going to leave my house. So I hit my push button. It's click, 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 going all the way up, going all the way up, going all the way up. And now it is at the top. Yay! So I pull out my driveway. And then what happens is I hit the down button. So down button. So, and now, oops, sorry, use the wrong switch. So down, it's going down, 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 down. So turn off my start button. Turn off my start button, go down, down, down. Then it finally hits this down limit switch, and everyone's happy. Now, a question that may come up, though, in some applications, maybe I have a system where I want to make sure something is down or something is up all the way before it goes all the way, okay? So, in that case, what I can do is add a condition right here saying when the garage door is up, or when the garage door, so wait, sorry, I got it. So when the garage door is up or the garage door is down, because when do I want the garage door to go up? When it's down at the bottom. If when I want to go down, I want it up at the top. All I got to do is put that as an initial start condition in my seal in. So now you'll see, and this is easier to do in real life. I'm working with a switch simulator, so I got to keep track of my switches. So if it doesn't work at 100%, it's because of my operator error, not because of it's not functional. So now I got my stop engaged. The motor's not on, but I'm kind of in limbo land. In reality, we would probably want to put in a jog feature to jog it up or jog it down directly. I ain't going to worry about this at that time. I just want to teach you the concept right here. And so now let's just say we are at the down. We are all the garage door is down at the bottom. So now I hit start. So it starts up, goes off the limit switch, and I leave my finger off, and now it's going all the way up. It's going all the way up. It's going all the way up, and then boom. Oops, gotta find the right limit switch, and boom, there it is. It drops off. So now I am up. I am not down. I am up. So now I can close the garage door, hit that switch. It's going to get off that limit switch. I can take my finger off the push button. It's going to keep going down, 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 down until it hits the down limit switch. Whoops, I got my switches mixed. There it is, down limit switch. But that's the concept. And showing you what I showed you, the basic motor interlock using limit switches to cut off stuff, that's the basic motor circuit. And with that, that's the building blocks for about every other circuit that we're going to do. Now, the only other thing we can add, if you really want to go crazy, is if I want to add a pilot light or something. So based upon this output here, so motor up, because remember, I can control things. I can do this multiple cases. I can put in an output here that will turn on when this motor is up, when the motor up engine is running. Or I could say when it's not running, turn on output 4. So all I did was just add another, little rung setup. And now go live. Let me hide this. So right now I have output 4 because motor up is not running. And now if I hit start, it's running, and there's not running. Running. I'm not doing a sequence. I just want to show you that just because I'm controlling it up here, I can use those same bits to affect statuses, and these could be pilot lights or another process. It doesn't quite matter. In many cases. So, but there we go. So that's another thing you can do as well. That's appropriate. But with that, you can do a lot of programming. So this is the starting point. You can go from there. Let me know if you have any questions. Thank you.